An encryption mechanism is being developed for the iRODS data grid based on the TLS encryption for secure data transport. A microservice is under development by the iRODS consortium to support encryption of files. The microservice will use the same algorithm employed for TLS secure transport. The encryption key will need to be saved in the data grid middleware. The microservice will have the form MSI encrypt star path, where star path refers to the logical path name of a file. A rule, HIPAA encrypt-check.r, has been developed to manage file encryption. The rule checks the access approval flag to determine whether encryption is required and checks a data encrypt flag to determine whether encryption has been done. The rule is available in LifeLab Zone Home R.W. Moore Rules, HIPAA encrypt-check.r. A description of the rule is provided in Chapter 6.50 of the Policy Examples Workbook. The rule HIPAA encrypt-check.r is shown here. The rule creates a query to find all files that have an access approval status flag with a value of 0. These are files that are not approved for public access. They should be encrypted. For each file in the list, a query is made for all of the descriptive metadata. If an attribute exists with the name data encrypt and has a value that is not equal to 1, the file has not been encrypted. The rule encrypts the file and removes the old data encrypt flag. A new attribute is added to the file with the data encrypt value set to 1. If the data encrypt flag does not exist, the file is encrypted and the metadata is added to the file. Note that in order to change a metadata attribute, the old version needs to be deleted and then the new version written into the system in place of the old one. When a file is encrypted, the file size changes and the persistent state information data size must be updated. The encryption algorithm type must be saved across all changes in technology since it is required to decrypt the file. An expectation is that the encryption algorithms will continue to evolve as computers become more powerful. The encryption key must be stored. Secure control of access to the encryption key is needed. The middleware will need to be able to decrypt the file, which requires access to the encryption key. If the file is shared, how is the encryption key shared? One solution for managing the encryption key is to maintain keys in the database, securely transfer a key to the client, encrypt data at the client, and decrypt data at the client. The key is securely transferred to the client for the decryption to take place. In order to avoid having the key compromised, the system may need to decrypt within the middleware, create a new encryption key, re-encrypt, and send the new file to the client. The sharing of the new encryption key will not compromise the original encryption. Take 7 minutes to complete exercise 90. Try encryption of a single file. This requires availability of the microservice MSI encrypt star path. Note that the file size changes on encryption. How much did the file size change? Please load a paragraph describing the result into the lifetime library in the sub-collection class INLS 624 by the end of today's class.